think we can go?
Yeah, sure.
Yep. Okay. Good afternoon, everybody. I'm Mike Weiner.
And I'm Kun Chen.
This is Mission Critical SQL Server, and Kun and I are both program managers on a team called SQL Cat. So to start off, we wanted to just give you guys a little insight into our team and what we're doing. So our team is part of the Cloud and Engineering Group, which is the same group that the SQL Server team is part of at Microsoft. And our team mission, our goals are really focused on three main components. The first is customer. So we work with a number of customers, some that are pushing the limits of our current product, and a number of customers that are testing new features and functionality of our products. We try and help make them successful. We do architecture reviews with them, design reviews. We have a lab in Redmond on campus that we bring a number of customers in to test their workloads at scale for perf, for availability, et cetera, as well. And in working with a number of those customers, we learn a lot. And we take those learnings, and our ears are always open to you, the community. We listen to the feedback, and we learn a lot, and we provide that back to the development teams, really, to improve the product. But it's not just about improving the product and making these singleton customers successful. It's about trying to make the entire community successful as well, and working with SQL Server. So we do have a blog site. We try and go to a number of conferences and a number of sessions that you will typically see. SQL Cat will have things like best practices or lessons learned attached to them, where we'll talk about kind of the work that we've done in real-world customer scenarios and try and let you learn from those learnings as well. Our primary focus area as well is the entire SQL stack. So we look at Azure SQL DB, SQL DW, which we announced earlier this week, SQL Server 2016, and SQL Server on Azure VM. So with that, the session objectives and takeaways. Really, the goal of this session is what we want to do is talk about a number of customers that we've been engaged with and how they're using SQL Server to satisfy their needs, their mission-critical needs in their workloads. So a number of these customers have come through the lab. We've worked with them for a number of years, and we'll kind of do about 5 case studies with different customers and talk about kind of their scenarios, their requirements, and how SQL Server is meeting those needs. We definitely, 2 comments. We definitely are open to questions. We love questions. If there are a lot of questions, we may have to defer some. We have a lot of slides that we want to get through and actually just information we want to deliver, so we may have to defer some to the end. Secondly, these customers who are partners of ours have been great in really letting us talk about their environments. There are certain things that we can't talk about their environments, so there may be a question where we may have to say, we just can't talk about that, or we just can't really answer that. It's nothing specific to the question. So what is mission critical? This means a lot of things to a number of different people. When we talk to a number of customers, they'll talk about requirements around high availability, performance, reliability, managing large amounts of data, et cetera. So number of quotes that we typically get from customers where they talk about, hey, this is mission critical and maybe perf related, maybe availability related again. You'll see a number of these themes as we talk through some of these customers and scenarios and what they're really trying to do with SQL Server. Okay. So with that, we want to, again, talk about these 5 customers and these core components of their business, do a little bit of deep dive into each of these customers, what they're doing with SQL Server, talk a little bit about their environment, and how SQL Server is meeting their mission-critical needs. So bwin Party. Has anybody heard of bwin Party before? Seen some stuff? Okay. Number of people. So bwin is the largest publicly listed online gaming platform. They have over 20 million registered users on their site. Again, they do casino-type gambling. They do sports gaming and betting. And actually, interestingly enough, they produce and actually offer simulcasts of a lot of live sporting events as well. So a huge number of users are on their site. Huge number of users are gambling and gaming on their site. You could just imagine, recently in the U.S., we just had this big boxing match that had a lot of gambling go on with it. Of course, events like the World Cup or the Super Bowl, and the amount of traffic that they get, and for those big events and people betting on all kinds of prop bets, not just the game in and of itself, but within the game, are significant. So just some facts and figures about them. About 14,000 bets are offered simultaneously, about 90 live events of video per day, about 70,000 payment transactions that they take on a daily basis. So they do have some security requirements as well. So what are their business requirements? Their quote that their architect talked about is failure is not an option. So downtime for them is significant impact to their business. They require 100% transactional consistency, 0 data loss, almost 5 nines availability, and they look at even loss of a data center that is super mission critical to them. So they incorporate that, and we'll talk a little bit about their architecture, what they do around that with SQL Server to account for that and still maintain their availability. Performance critical. They have a large number of users that are using the site simultaneously, and performance is really critical to them. They want their customers to have a good experience, and the more customers that you have that are actually betting and gaming, of course, the more revenue that you can produce. And happy customers are good customers. Of course, they have security constraints as well and considerations. So they, of course, are working with financial data and need to maintain PCI and privacy requirements. So let's talk about bwin and a little bit about their overall SQL Server environment. They have over 100 SQL Server instances in their environment. About 98% of those are running on SQL Server 2014. The other 1 or 2% are on SQL Server 2012. Again, that equates to over 1,400 databases. The last 2 points right here, pretty impressive. About 450,000 plus SQL statements per second executed on one of their servers. Overall, for their environment, over 500 billion database transactions a day, again, running through the SQL Server environment. So what do they use SQL Server for? Core components of their solution, financial transactions. Their financial transactions all go through SQL Server. The gaming environments, be it casino games or other betting games. And tracking user state through the system, very important to them too. So they need to track all these users as they go through all these different components. I'll show you an example on the next slide of a teeny bit of their environment, and very, very important for their business to run. Just as a FYI to people, their solutions are primarily scale up, and they do use almost all commodity hardware. So 4-socket boxes is their typical one, and we have an example of what they're using in their environment in a bit later slide. So this slide. So I expected some laughs, and I talked to bwin about this, and we said, all right, well, what kind of slide can we give that gives people a perception of their architecture? And this is going to go for the most abstract or confusing slide, maybe at the conference. That's what we're going for here. But just 2 points that I wanted to call out here. This is just a high-level snapshot of some of their in part of their environment, right, from an architectural perspective. All the green circles are databases. All the green circles are SQL Server databases in their particular environment. The bigger the databases are, actually stands for 2 things in their environment. 1, size, and 2, how critical it is. So I think you could probably see 11 or 12 circles. About 11 of those 12 are green, and all the big ones are SQL Server. This doesn't actually count for a couple of the ones that I'm going to talk about in a minute that are specific application implementations. Okay. So first thing, again, failure not an option. bwin has very specific HADR requirements. So let's talk a little bit about their application requirements and how they're kind of meeting that with SQL Server. Again, they have multiple databases. They use SQL Server always-on availability groups for almost all their HADR needs. They plan for the worst-case scenario, which is a loss of a data center in their particular case. Their RPO is 0 data loss. Their RTO is about 10 seconds or less, even in terms of data center failure, right? So they need to be up, back, and running, even if a data center goes down in under 10 seconds. The availability numbers that they've been achieving, these are a little bit old, but basically hit the same point. I'm not sure they went up. They certainly didn't go down, but greater than 4 nines availability. And even when they're doing maintenance on those particular systems, again, they still need to maintain that, right? So it's just not online availability. Even if they're doing things to those particular boxes, they still maintain those plus 4 nines plus. So I have a picture on the next slide, but they have multiple data centers. They actually use 3 data centers primarily in their environment. They have a primary, a DR, and then a third data center that in particular for always-on availability groups they utilize for quorum. And this is a snapshot of basically their typical scenario that they will use for implementing always-on availability groups. So no really weird secret sauce or anything like that. They have 4 nodes. They have a primary and a number of secondary replicas. They have a couple in doing sync. Actually, they have sync across data centers, which is a little bit unique. But again, it meets their needs of having a RTO of under 10 seconds, even after data center loss and failure. So a little bit of a picture of their scenario. Again, data center 1, data center 2. Data center 3 allows them to maintain quorum. All of the nodes and the file share witness have votes within the cluster to maintain this. And again, their auto failover partner and always-on availability groups is to that second data center. Okay, so next we're going to talk a little bit about kind of their performance critical. They have extreme performance considerations as well. So BWin actually came and worked with us on an application integrating into 2014. It's basically ASP.NET Session State. So Session State, BWin utilizes it to basically track their users as they come. Their user experience is tied to as the user comes into their environment. They track that in a Session State database. As users are moving around, they will track that in a Session State database. So it controls the user context as they move throughout the system. So the shorter time it takes to actually do updates into that table, the better experience users can have. They can move around more freely, et cetera. The opposite is true, of course, if things are taking a long time to actually map to session state, the user experience is potentially a lot worse. So their initial configuration, actually in earlier versions of SQL and how they'd implemented this, and this is just a relational database kind of construct, is they could scale out their web tier infinitely. It was pretty static. But all their users had to go to this single database. And per database, they could get about 15,000 concurrent users using that particular system. So they did some logical scaling out of their application and their database, and they actually, to meet their business need of over 250,000 users on their system, they had 18 SQL Server instances that were handling that. So what we worked with them on is in SQL Server 2014, we have a new feature called in-memory OLTP. These are the details on how they implemented in-memory OLTP. So I won't go through all of these. I'll just call out a couple of interesting aspects. They are kind of on the high end in terms of basically the amount of memory in in-memory OLTP objects. Again, in-memory OLTP, you can have tables that are memory optimized. You don't have to have the entire database. You can have other components of that database that are standard disk-based tables, et cetera. So about 20 gig of memory in memory optimized tables. We have some different durability constructs. They use the schema-only table because if their session state, if their server did end up going down, people would actually have to log in. So they were OK with losing that particular data. You can see some of the information around the hardware. The development time, I think, is pretty interesting. So they did an initial prototype of this in about 2 days. They had to make no application or web code changes to implement in-memory OLTP. They've been in production for about 2 years. And again, before the migration, This is what they were really getting. And after the migration, they basically consolidated to one server from the 18. Question?
Why was the HT disabled?
Why was what?
HT disabled.
Hyper-threading.
Why was it disabled?
Yeah.
They just weren't using it. So the question was on the previous slide, why was hyper-threading disabled? That's the practice that they're implementing in their environment.
Is that best practice by SQL Server team?
Not anymore.
That's what I'm
So yeah, the question is that the best practice in terms of having hyper-threading on or off? There are some nuances there, so maybe we'll take it a little bit offline. I think we'll take that. We should take that one offline.
Sure.
Yeah. So again, about 250,000 batch requests, they were able to consolidate to one server. So you heard what I said about it, but what we're going to do is play a video by bwin, and you can hear what they said about it. The only caveat that I want to specifically call out is this video was done a little bit before. bwin was an early adopter. They went in before SQL Server 2014 actually released an RTM. They went into production with this. So the code name for in-memory OLTP is called Hackathon. They refer to it as Hackathon a lot.
Well, to describe Hackathon in 2 words, it's wicked fast.
It's incredibly fast.
bwin is the largest regulated online gaming company in the world. The online gaming market is a very competitive market. Either you're the first or you're not present at all. When you want to have competitive speed, you also have to have technology speed. And this is part of our mission statement, to be agile, to be on the front, to be the best. We are pretty much on the edge of what is possible. We had a problem, we needed a solution. To keep the session information for the user, we have one single point, and this is SQL Server database that more or less coordinates all the web servers. And there is a natural limit in this application that only allows us to handle about 15,000 requests per second.
Every transaction goes over a single point. This is the session state server.
15,000 requests per second might sound like a lot, but it isn't when you come into our business and into our growth rates.
It didn't scale anymore. We could put more machines to it, more power to it, but it didn't scale anymore.
Microsoft cracked that nut for us. Hackathon was the solution that we were waiting for. We thought that with Hackathon we would maybe double the number that we had before, so from 15,000 up to 30,000. We were pretty amazed when we hit the first test run with 150,000. From that on, it only went up. Right now, the fastest test that we have scaled out at about 250,000. The network infrastructure is definitely now becoming the bottleneck, both from a latency point of view, also from a throughput. It's actually a good problem to have. In contrast to other solutions on the market and other vendors, Hackathon integrates seamlessly into the SQL Server engine. So if you know SQL Server, then you know Hackathon as well. Hackathon is a winning bet for us.
And just one follow-up on that. Rick, in that statement, said about 250,000, and that's kind of what they were achieving. We have gone back into, again, labs actually hit well over 400,000 batch requests per second in their environment on doing that. So that's a little bit of a deep dive into kind of bwin, how they're using SQL Server. Next up, I suspect some people have heard of NASDAQ. So NASDAQ, stock exchange, established in 1971 as the world's first electronic stock exchange. 26 markets, global, worldwide presence, trading, clearing, market surveillance systems. Really business critical, not just internally to NASDAQ as a whole, but to the world financial markets and systems. So some of the business requirements that NASDAQ had, certainly during their business day, typically about 9 hours in terms of the trading days in the US, about 100%, absolutely 100% availability. Performance to them is as critical as availability. If they're not getting the performance that they need to the data, which again is in terms of latency, throughput and latency performance, and they look at things actually under microseconds. All the discussions with them are maybe milliseconds, likely microseconds. probably nanoseconds. And managing large data volumes. So we'll talk a little bit about how NASDAQ is actually working with petabytes worth of data inside SQL Server as well. So their overall SQL Server environment, they have almost 200 production SQL Server instances at NASDAQ. They're doing billions and billions of transactions a day through SQL Server. They have over 2 petabytes of raw data that they're storing in SQL Server. So the architecture has to support 5 nines uptime requirement. Again, 100% on the mission critical apps during the business day. Just from a perspective, when typically talking to them, they'll say things like, hey, we really need to support this for something like 32,800 seconds per day. So they really look at things in terms of seconds and low latencies, et cetera, which is about the 9 hours of the business trading day. All their critical databases are on fault-tolerant clusters. They have a mixed environment in terms of some SQL Server 2014, some SQL Server 2012, et cetera. So they use always-on availability groups and database mirroring for their HA and DR environments and implementations. And again, availability to them is not just measured in terms of basically, can I access this data, but with what speed can I access this data? Or what latency can I actually access this data? For them, and again, this is just kind of the model in terms of how they think. The solutions are all developed with availability and performance in mind. So it's not just the database, certainly to them, it's their entire solution, latency across that entire solution, and availability across that entire solution. So I'm going to give an example of one of the solutions that they've implemented on top of SQL Server. This is a single high transaction throughput system. They're executing about 280,000 business transactions a second through it. Actually, each business transaction is about 5 data access calls or data manipulation calls. So that's over 1 million data manipulation calls per second in the database. Latency per business transaction in the microseconds. So it has a real-time nature or flow, obviously, to this data. As low latency as they can get. 0 would be perfect. It's also mission critical, of course, in terms of availability. And the last statement here in terms of the same operations and processes applied across their environment. So they're not a whole Windows SQL Server environment. They have a lot of different technologies in their environment. Previously, they had solutions such as mainframes and things of that nature. But the process and the philosophies that they use on the Windows and SQL boxes, on their other type of environments, is all the same. Right? To them, it's all about availability, performance, et cetera. They don't treat them differently. And that model has served them very well in terms of basically getting the most performance and availability out of these particular systems. So let's do a little bit of a drill down in terms of a system that NASDAQ calls the data archive and some of the large data volumes that they're handling. So this project maintains all the U.S. equities and options trading data. They're required to keep that online for 7 years. It's processing tens of billions of transactions a day, over 1 million transactions per second, peaks up to about 10 million transactions per second. Data is used to comply with government regulations, et cetera, et cetera. They have some queries that can be longer running, but they have requirements around how long, again, it takes to access certain data. Some needs to be much more real time. So they're taking on about 500 terabytes per year. Right now, it's totaling a little over 2 petabytes of uncompressed data. The largest table is approaching around 10 terabytes. So again, NASDAQ, in this particular case, also was an early adopter of SQL Server 2014. Their goals around SQL Server 2014 were to better manage data growth, improve query performance, and ultimately reduce database maintenance time for their DBAs as well. So I'll talk a little bit about what NASDAQ did in the next slide, but a little bit more high with 2014 specifically and our in-memory technology. But a couple other considerations that they have. Again, data at this scale really need to break things down into manageable pieces. So they did some separation into different databases in terms of subject area and in terms of year. So they maintain yearly databases within a SQL Server instance. They rely heavily on table and index partitioning, 255 partitions per database, really per table per database. It's 25,000 file groups. They use partition alignment to easily move data around in their particular environment. Utilize file group backups, so you're not backing up petabytes and petabytes or terabytes and terabytes of data. Much more manageable chunks. And again, they're heavily taking advantage of compression features. So NASDAQ went and looked at our in-memory column store in SQL Server 2014 to help with all those issues that they had. One of the biggest gains that they got, we're very happy with, was the compression that they got by implementing the clustered column store index. So this is an example of, this is their year 2012 database. Again, their compression savings, they got about 5 to 8x compression over their uncompressed data. They had everything in page compressed format, so it was about 2 to 4x, depending on the data types and the data in those particular tables. They used backup compression on top of the clustered column store index, got about 2x compression on top of that. And there's a feature in the column store index called archival compression. You can create it with archival compression as well. Got about 20% gains on top of the compression after that. In this particular case, 500 terabytes raw, and then you're managing just over 100 terabytes potentially, and on the backup even less. So a few other gains that they got with the column store index. They got rid of all these other indexes that they had that basically needed to support these queries. Ultimately, they ended up getting better perf on their loads. Query performance reduced dramatically. Their single day reduced from, say, 5 seconds to 1 second, but the historical reports across multiple days, potentially across multiple years, although typically most of their queries kind of go first day, week, 30 days, maybe 90 days out, up to about a year. Significant gains. And again, the migration aspect was transparent to the end users. No application code changes. In fact, we did this system. Before we did this system, we did another data warehouse that they had that was about 20 terabytes and converted that one over as well. So with that, I kind of told you guys a little bit about the data archive project, but we'll go to another video and let NASDAQ tell you a little bit about that as well.
NASDAQ is one of the world's largest exchange companies and one of the largest market technology companies. We operate 26 of our own exchanges in 80 markets throughout the world in 50 different countries on 6 continents. The role of IT is to help our customers have better insight and visibility into the markets. Data is the lifeblood of the company.
NASDAQ presents some interesting challenges. They're an interesting mix of both very fast data and very large data.
This particular system in question handles billions of transactions per day, multiple petabytes of online data, and has single tables with quintillions of records of business transactions. So managing a petabyte of data takes a lot of planning. You can't turn quickly on a dime.
Basically, you run into time constraints. As the database gets to a certain size, you only have a certain amount of hours in the day to process it. Users have to use it. They want their answers.
Within SQL 2014, they have the introduction of the in-memory column store, which allows us to better manage larger pools of data. We've seen, on average, a 50% reduction in the amount of data that is physically stored on disk. And not only does it help us save money, but it helps us more efficiently and effectively deliver data to our consumers.
The migration allowed us to rework some of the queries. Some of the queries would take almost a day or two to run. But once we bring them over to SQL 2014, put the column store indexing on there, now they run in minutes. Our goal is to migrate the data to a platform where it's more accessible to the end user. The faster the answers they get, the more informed business decisions they can make. The value of the data really rests in the imagination of the user querying it.
Okay. Any questions? Yes, sir. Could you go to the microphone?
Okay, repeat
please?
the question. That's fine. The question is,
I'll repeat.
Hello, testing.
Yeah.
Did they use always on?
So they do use always-on availability groups, yeah, for some of their HADR. For some of the older systems, they use database mirroring as well. Yes.
Thank you.
They also use always-on failover clusters, right? Failover cluster instances as well for some of the systems.
this question here.
How they achieve 100% availability?
Okay, so the question,
Yeah.
the question is how do they achieve 100% availability? So ultimately, there are no guarantees that you're going to achieve that. I mean, they have a number of different aspects in their environment where they'll look at redundancy, redundant paths, again, whether it be different data centers, availability group features, and the high availability disaster recovery features, et cetera. They have availability, whether it be, again, not just in their database, but in their app and their overall solution tier that maps to that. So that's their goal. There's no particular guarantee on doing that, but that's what they need to achieve. It's actually just their business requirement.
Yeah, let's be honest, right? There's no such thing as 100% availability in this world, right? It doesn't really matter how many instances you have. It's the way how you design application to be as close as possible. In this case, we probably can say, I don't know, 6 nines, 7 nines, 8 nines, right? That's the best we can do with the current technologies we have, right?
Yes, sir.
So what kind of disk subsystem were they using to get that kind of throughput?
Okay. Yeah, good question. This will let me actually talk about a couple of customers, at least at a high level. So the question was, what kind of disk subsystem were they using to get that throughput? And so I'm going to make a general comment instead of specifically talking about particular vendors, although we do actually happen to mention one or two in the next scenario. So BUIN, NASDAQ, actually the next customer that we're going to talk about is Quanta Computers. They're all using different types of hardware and different types of disk subsystems. So some customers are using SANs, some are using flash. They're both actually meeting the needs in both cases. Certainly SANs may have some flash in front of them. It's not just the end hard disk drive, but in the BUIN case and in the NASDAQ case, for all their systems, they're using commodity boxes, 4 socket type systems. The BUIN case, they had a decent amount of memory. They've just upgraded, so their average is about now 512 gig of memory, but before that it was 256. And again, just 4 socket boxes. Again, BUIN, they have the updated, so I talked about the 60 cores there, so that's the 4 socket 15 core, which is one of the newer models. But those are 4 socket implementations. The next one we'll talk about, Quanta, they're 8 socket. They're using the DL980. But so it varies. You can meet it in different ways. And actually, worked with a number of different SAN vendors and a number of different flash vendors, and been able to meet extremely high performance needs in both cases.
Yeah, it really depends on customer's workload, right? So it depends on how many IOPS you need, and also need the latency, for example, right? So of course, the flash disk and SSDs, they probably have some much lower latency, but even traditional SAN disks, they can give you a very high throughput, right? And I had a case.
And low latency.
Yeah, of course. So depends on how you design the solution, and I've seen some customers actually trying to scale out the application tier, so each workload on particular SQL instance is actually much lower. They don't need that much higher throughput per se, right? Whereas some other cases, they're going to try to scale up and trying to have a SQL instance as a single point of the truth, and they need a much higher IOPS throughput and that kind of things. So you can have different ways to tackle that problem.
Yeah, I would definitely say there's not one size fits all. And I think that these actually are good examples. Like I said, these solutions that you'll see we'll talk about, some of them absolutely use SANs. And a number of them absolutely use flash. Any other questions? Okay, so let's talk about the next customer. Sorry, Quanta. Okay, so Quanta Computer, they're a company out of Taiwan. They're a manufacturer. They manufacture for a number of name brand systems. They also do their own self-manufacturing of products. Again, pretty high annual revenue that they're concerned with as well. And kind of an innovative computing technology company as well. So their business requirements for availability, they have a 24/7 data availability need. For performance, they have a large number of concurrent users that they're concerned with on the system. And very similar to the BWINs, to the NASDAQs, their execution times, they need it as low latency as possible. So they're looking at sub-millisecond execution times for a large percentage of their workload. End-of-month reporting is a big issue for them as well. They do a lot of financial reporting that they run on the SQL Server instances, so making that very fast and efficient is important. And data size and volume, again, as well, they're suffering from some of the similar considerations as others, ever-increasing data volume size and managing that. So SQL Server is really the heart of Quanta's system. It runs their line of business app, running SAP on top of it. It's used for financials, logistics, worldwide supply chain. So these are all the businesses, really, and components of the business that Quanta is servicing. So if you kind of look in this smaller middle component here, you have finance management, you have your manufacturing and engineering system, your purchasing, your warehousing, et cetera, et cetera. A little bit more on the outside ring, you have your supply chain management system, you have your business processing model, et cetera. Again, SQL Server and the ERP system is really at the heart. If this system were to go down, basically their entire business could potentially go to a standstill. So thousands of workers, and again, their entire manufacturing and financial components. So let's jump a little bit and talk about a little bit about the evolution of their system and how they kind of came to this point, and then we'll talk about some of the technologies that they used in SQL Server and how they implemented SQL a little bit. So initially, Quanta had actually a large number of systems that were kind of servicing different components of their environment. And this is a number of years ago. They consolidated this into one SAP SQL Server system. So very large SAP workload. They needed to and wanted to scale up on this particular system, so they are using an 8-socket HP DL980 in their particular environment. They are using Fusion IO drives for their low latency perf considerations. They have about 1 terabyte of memory in the system as well. So again, consolidating a lot of business lines into this one core business line in the middle of their system. So high availability, very similar to the other customers. They're using always-on availability groups for their HA environment. So within the same data center, they're using synchronous replication between the DL980s. They do, to the remote data center, they use log shipping. So they have a need for a delay right there in moving that data over. But they've tested it with availability groups, again, with their peak load, which is pretty significant. We'll talk about some of the numbers that they're actually achieving on their peak load. Their throughput is fine. And again, they utilize it so they can use this for their all their availability needs. So data volumes. We started working with Quanta around the 2009 timeframe. They happened to be on SQL Server 2008 at the time. They did all the consolidation of the multiple systems, and their average growth was around 500 gig per month. So we worked with them a lot on using the compression features that are in SQL Server 2008, specifically page compression. They went all to page compression on this. So they did it over time, and they rolled out the page compression. There was no impact that they noticed in terms of the performance of their workload, or no negative impact, I should say. They noticed positive impact, but no negative impact. And really nice factors of compression that they got in working with these large data sets. So typical was about 5x, in some cases even 10x compression ratios. So today, their SAP ERP database is about 9.7 terabytes on average. They do some aggressive cleanup to keep it right around that 10 terabyte limit. Again, uncompressed, that'd be about 45 terabytes that are working with and managing. And the performance characteristics, about 5,000 users in the system, peak times, over 1,200 concurrent users. The transactions, we kind of talk about the SAP team. We'll always talk about this in terms of SAP dialogue steps, again, for the overall solution. What that really maps to on the SQL side, over 25 million database transactions per day. And again, perf latency, very sensitive, right? So they're looking at millisecond, sub-millisecond performance. And again, the CPU utilization here, just as an example for their particular environment, so it's not overstressed by any particular measure. They get up to about 70% CPU when they're doing peak end reporting. So with that, I'll turn it over to Kuhn to talk about our last two customers.
All right. SAT, anybody knows SAT? Oh, there's a question back there.
Oh, yeah, question.
Did they ever compare with SAP HANA?
So the question is, did they do a comparison with SAP HANA?
Or SAP try to do any HANA comparison?
Okay. Yeah, so the question is, did SAP try to do any comparison? I would say none that I know of, but my overall comment is actually our team, we have a specific people on our team that actually sit with SAP. It's a very tight relationship with the SQL Server team and the SQL Cat team working with SAP. So when we're working with a number of these customers, I think that this is the only thing I know that they particularly tested. I don't know if they did any comparisons, but it's absolutely meeting the needs of their business today. I could say that they're looking at SQL Server 2014. They're on SQL Server 2012 right now. They're actively looking at SQL Server 2014. So they are definitely happy with the solution as is.
Cool. Well, I was going to ask of the audience if anybody knows about SAT, but looks like we already shown the full name. So it's not the traditional SAT in the US. Actually, it's SAT in Mexico. These guys actually, let me talk about the company profile. This is not really a company, but it's a government organization, right? These guys are responsible for tax invoices collection, processing, this kind of financial processing tasks. This is more like a US IRS, especially in the tax season, they're getting really, really busy, right? So this, back a few years ago, in 2010, the government of Mexico, actually the president of Mexico, announced the plan to digitize all the commercial invoices and also these tax invoices. And their goal is trying to make it in production by January 2011, right? So between the time when they made the announcement back in September 2010 and January 2011, they got only 4 months, right, to go in production with something that can support this volume. When we talk the volume, it's about 10 million invoices a day. They're projected to go over 150 million invoices a day, right? So that's the kind of the volume they have to support. And also from the availability perspective, they want to make sure the system is at least 4 lines online all the time, right? 4 lines pretty much, I think it's like 5 or 6 minutes a month. That's the downtime you can achieve. So with 4 months of before, actually there's something else. So we actually, Microsoft, there's this project actually, CAT team, but also Microsoft Consulting Services and the premium support team, we put together a plan to compete with the 2 more competitors because There's time constraint, but also there's budget constraint, right? There's a government, they have a limited budget. Microsoft actually won this project to meet all the goals in terms of the time, in terms of the budget. We actually introduced this Azure solution architecture to implement this solution. This was done in 4 months, right? Keep that in mind. This is a mission-critical solution, support up to 10 to 20 million invoices a day back in 2011. So let me walk through the diagram a little bit, and I can take some questions. But just for the confidential reasons, I cannot really go into a lot of details here. So already kind of elevated to a fairly high level. On the left-hand side, these are you can call on-premise users or companies that need to upload invoices. And all these invoices in raw data format can be uploaded into the Azure platform. Now, this particular case, all the invoices, the raw data is in the blob storage. And all the metadata goes into the SQL database, or SQL Server running the SQL VMs. So they do have a kind of mixed environment on Azure today, which we support today, which is either Azure DB running as a managed service, or SQL Server running as a VM, which is we call IaaS. Okay, so they use both. So the goal, actually, this system can support up to about 30 terabytes of the data. This is talking about raw data. But also they have multi-terabytes of the metadata in SQL Server and the SQL database today. So once this data have been in the Azure platform, they're deployed multiple worker role, web role instances to process the invoices. There are a lot of the internal stuff happening here. I want to go into the details, including authentication, security, even availability aspects of this. But they do support not just the uploading, but also allowing the users or companies to log in the portal. This is showing at the top, the end user portal. So they can log in the system, they can check the SQL database because they don't want to look at the raw data, right? They just want to look at the metadata in SQL DB or SQL Server VMs to check the status of the invoices. Are these invoices uploaded correctly? If I need to cancel them, make any changes, the system allows them to do this through the portal. They also have the internal portal, basically providing capabilities for the SAT users, the logon system. They can actually check. It's more like a BI, operational analytics information, right? It's more like information about fraud detection, for example, right? So they can use this portal to, again, this portal is connected to the SQL databases without looking at the raw data, right? Any questions about this? I talked about blob storage and talk about these databases. Maybe I can explain a little bit more about the reason they use in both the SQL VMs, the SQL Azure database. They actually started with Azure SQL databases back in 2011. They had a few databases. I'm not sure if anybody familiar with Azure DB back then. When we started Azure DB, we actually supported as kind of, we call it a multi-tenant environment, meaning your database sitting on the same machine as other customers sharing the same resources. There was a little bit of performance impact because of that architecture, right? Basically, if you have your neighbors, consuming a lot of resources, and you happen to be on the same node as those databases, you basically be starving. You're not getting the resource as you want. So back then there was some proof impact to SAT, right? This is mission-critical applications, performance issues causing, in their perspective, is downtime for them, right? So they actually moved some of those Azure databases to SQL VMs. SQL VMs is more like on-premise SQL Server boxes. You have the full control, right? From the OS stack all the way to the SQL Server to those management tasks. You can do anything you want, just as you do for SQL Server boxes today. In that case, also, it provides more isolation, right? So you're not sharing that particular VM with anybody else. You're just hosting a bunch of databases together, right? But I do want to say this is, today that's the reality. They have to running like both SQL VMs, SQL databases. But in the long term, we're actually trying to, even today, we're still working with SAT, after they went production, just make a solution more robust, more, high availability, more performant. So we're actually exploring both options here. There was one option we're actually thinking about StrateGDB. I'm not sure if anybody attended the session that you did yesterday. Also, that did a demo in the keynote where you can bridge data. Basically, you can bridge between your SQL server and the SQL database on the cloud. In this case, actually, SAT has data already on the cloud, right? In SQL Server, you're running the VM on the cloud. Also, you have SQL database as a managed service. In this case, they don't really even need to, manage them, explicitly. They can just use in StrateGDB to stretch data from the SQL VM into the AreaDB. Okay, that's one way. We're exploring that possibility. The other way, actually, is just using SQL DB because, this week or last week, we announced this elastic pool on the AreaDB, right? Basically, give you a pool of resources to share within your own tenants, not sharing that pool with anybody else, right? That gives you the isolation. Remember I talked about this noisy neighbor kind of problem when the AreaDB was in the old days, but now we have this solution to isolate it even more, right? To give you that pool, and they do have multiple databases. They can just put a bunch of databases in the same pool, and they all share the resources within themselves without sharing it with anybody else. And so I talked about these two possible solutions. For StrateGDB, there's a concept of code the warm data. So in that solution, actually, we're talking about maybe keep the warm data in the SQL VM and just archiving the cold data into the SQL DB. So that was the reason I put the code of warm data in there. This is the invoices you can think about. After a year or after 2 years, you may want to archive the old invoice data, the metadata, into SQL DB instead of keeping them in the SQL VMs. For SQL VMs, they do use the always-on technologies. This is based on the SQL Server 2014. So this is kind of the diagram showing the SQL VM running on Azure as IaaS. And they have multiple setups like this. So I'm showing like 3 of those, but actually they have more than that. Each always-on replica actually has more than 20 data files. Each data file is like 500 gig database in size. Now, I'm not sure if you know, but each disk on Azure VM, if you attach a disk to the SQL VM, we can give you a maximum up to 1 terabyte in size. There's a reason they're using 500 gig because they want to make the maintenance jobs easier to run and manage, right? If you're running a reindex, running backups, small database and make it more efficient, right? It's not because of the Azure limitations, just because from their workload perspective, make it easier for them to manage. But the reason, actually, in this case, they're not using attached disks. Disks was they have back in this was like done in 2000. This is probably 2 years ago when I moved to this blob storage directly because attached disks on the SQL VMs 1.5 years ago we only support up to 16 data files or attached disks, right? If you on SQL Server 2014 and also SQL 2016, we actually support running a database files directly on the blob storage instead of attached disks. Okay, so that's what they are taking advantage of. They can go beyond 16, but nowadays we actually have more than 20, right? We have 32 or even higher. And also another best practice from their perspectives is they're using multiple storage accounts to give them more IOs. This is the way on Azure, which is a little bit different on on-premise SQL Server. On SQL Server, if you're running everything together, you buy hardware, you can buy SAN, you can buy flash disks. But on Azure, actually, it's more like scale-out storage, right? So each storage account has a limited capacity or throughput for you to use. So one of the best practices is if you have so many data files hosted by the database, you should consider using multiple storage accounts to spread out I/O throughput or workload. Recently, we released the premium storage on Azure, right? So they're actually one of the customers, early adopters. They're testing premium storage, which give you a guaranteed amount of IOPS, right? We give you up to 50,000 IOPS, I believe, for each storage account. So they're actually taking advantage of that new feature to even push the envelope a little bit more, getting more performance out of it. Any questions? Yes.
20+ data files per database.
Yes. Correct.
And each data file is 500 gig.
Yes. Yeah. The question was the size and number of database files for each database. they have multiple databases, right? In that case, but we do support, if you have like one single database, multiple terabytes, you can spread out those data files and log files. Well, let me move on to terminals. This last customer we have, not the list. They're actually one of the ISVs. We've been working with it for years. I actually started when I joined the CAD team. This is one of the first customers I got, kind of inherited from my predecessors. They're ISV in the financial banking industry. So what they do is they create this software package, for the core banking businesses, and they sell them to the banks, small, medium, big banks, right? So they're kind of all over the place, right? They do retail banking, they do corporate and correspondent banking, they do university banking, they do microfinance banking. So they're trying to cover as much market as possible, right? From their business requirements, core banking means almost zero downtime. I shouldn't say absolute zero downtime, but as close as possible, just like 100% availability, right? There's no concept of zero downtime. But they just want trying to make, especially when the banks are open, right, during the day, they want to make sure, customer can get in, they can get a cash, they can deposit checks, et cetera, right? So this is a true mission critical. If the bank, if this software is done offline, they can do all this transaction stuff. So that's particularly true for the online transactions. So typically for the banking, I'm not sure if you're familiar with this, the banking business, they have two types of workloads. Online banking, online transaction. It's not, when I say online, it's not going to the website and just doing that kind of things. It's more like transactions like getting cash, from ATM, deposit check. This type of what we call online transactions. The second workload actually they're called the close of business workload. So after banks close, they have to do a batch job every night, every month, every quarter to consolidate all the transactions, to do lots of these quite intensive job, the back-end jobs, to make sure there's no errors and they can compile all that stuff together, right? So these two types of transactions have different characteristics. Online transactions is more like, kind of random transactions happening throughout the day, versus close the business actually happening, in the off-peak time or during the close time. But both are very important because even for close the business, they have a very stringent requirements in terms of how long they can finish the job. Their industry standard is 4-hour windows, right? So after the bank closed, they have at the most 4-hour window to finish that, we call it COB, close the business. Otherwise, the bank may not be able to open in the next morning, right? So it's a very, very mission, business critical workload for them as well. Yeah, I'm just showing you a couple customers. They actually have hundreds, thousands of customers. On the left, this is Sinopec, based in Taiwan. They have over 3 million accounts in their banking system. This was almost like 4 or 5 years ago. And Shanghai, Bank of Shanghai, based in mainland China, they actually is much bigger. Back then, they had up to 13 million accounts. Right? So terminals, again, they cover lots of different sizes of banks. Even North America, they have lots of customers, like a North Shore Credit Union, based in Canada, Vancouver. They have quite a lot of customers, but very concentrated on Europe, Asia, APAC area, limited in North America. This kind of high level diagram of their architecture, very, very traditional multi-tier architecture. Clients log into the system, going through the web servers, which has built-in connectivity, they call it direct connection, which has the logic to talk to different backend systems. The application, when I say non-stop, meaning they're always online, they can scale out very easily. I'll show a different diagram for the benchmark, tell a little bit more. But the backend, they're running SQL Server. They were running SQL 2008, 2008 R2, 2012. Even today, they're running 2014 in certain clients. They were using either Windows failover clustering or using always on today. So a couple years back, we did a benchmark with the terminals. This was based on SQL Server 2012. We actually did more work with these guys these days. We just don't have the public reference yet. So this was, I think, 2 or 3 years ago when we did this benchmark. This was based on Windows 2008 R2, SQL Server 2012 Enterprise Edition. In terms of hardware we're using, SQL Server was running on a HP DL980 G7 with 80-core CPUs, 1 terabyte of memory, and using XIO storage. XIO actually is kind of hybrid storage. With the high level is SSD, and underneath actually a lot of spindle disks, right? So give you more throughput. Depends on, they have a very intelligent caching mechanism basically built in the storage. The hard data stay in the SSD versus cold data in the spindles, and they can swap, in a runtime dynamically, and make it very, very efficient. Now, on the right-hand side, these are the application tiers. Again, they're running all kinds of different hardware. Their applications are designed to scale out. Again, they can use HP DL360 with 12-core machine. They also can use like a 2-core machine at the bottom. And in the middle, they have all different kinds of hardware. This actually was exactly the hardware spec we use in the lab, just because they just want to test different hardware, make sure the application can behave the same way, and they can scale almost linearly from the application perspective. So at the end of the benchmark, I just want to talk, this is all public. You can go online and check out the case study. And also we had a white paper talking about the detailed SQL Server configuration, the tricks we did, and that kind of things, right? So, but this is the end results. Again, this is on SQL Server 2012. For the online transaction, I talk about 2 workloads. Online transactions, which is critical for them during the daytime, over 11,000 transactions per second during the peak time. And for the close of business, they're getting over 10,000. They call intrinsic accrual and capitalizations. If you're in the banking industry, you probably know what that means. But this is a pretty critical part of this close of business workload. They were able to finish this COB within an hour, 1 hour window. This is based on 25 million customer accounts, right? Think about the Bank of Shanghai, which had like 13 million accounts. So this is how big we can go to, 25 million. We actually did even higher numbers, which cannot disclose in this case. But an average database throughput getting over 260,000 per second. This including transactions, but also including all those queries for reporting purposes. From the scalability perspective, they get almost 95% linear scalability as they increase the number of agents. Remember the number of application servers they can add to this scale-out architecture. They can keep adding application instances, keep adding in this case they're called agents. We can see almost a linear scalability from the whole system, including single SQL Server database. So again, this is our conclusion was the combination of the T24, which is the product name of the terminals, and the Microsoft technology, basically the Windows and SQL Server, provides the optimal solution even for the world's largest banks. Any questions?
Okay. So in summary, again, what we tried to do here is give you guys some snapshots into different customers that are using SQL Server for their mission-critical environments. We talked about a number of different businesses, a number of different functions, geographies, and kind of architectures for those solutions, where SQL Server is basically meeting those needs today. And with that, we'll take any questions. We can take questions from the microphone, or you can come up to us afterwards. And we appreciate the time. Thank you.
Thanks.
Oh, we also, in the appendix, we have case studies for all the customers, public case studies. And please fill out your evals.